Good morning, good afternoon, or good evening, depending on where you are in the world. And welcome to this Tech Strong Learning experience brought to you by AWS and Gremlin. My name is Cody, and I'd like to welcome you back to Tech Strong Learning. We have an exciting panel ahead, but before we get that ball rolling, we do have a couple of housekeeping notes I'd like to review. First, today's session is being recorded, so if you miss any of our discussion, perhaps you'd like to rewatch or maybe share with a friend. The on-demand recording will be made available shortly after we conclude this live session today. If you'd like to interact with us, there are a couple of options for you to do so. The first of which is the chat tab, which can be found on the right side of your screen. I'd like you to start testing out that functionality for us by letting us know from where you are joining. If you have any specific questions, we do want you to send those in using the Q&A tab. That Q&A tab can be found directly to the right of the chat tab, and sending your questions to that Q&A section just ensures that we can keep track of them better. So if you can send them in there, we'll have a better likelihood of getting to your question. We don't have any handouts at the moment, but about halfway through our presentation today, I will be releasing a couple of handouts. So I will let you know in the chat as well as in my closing remarks that those are available. And of course, before we close out, we will be giving away 4 $25 Amazon gift cards. So be sure to stick around for the duration of our conversation. So the topic today is confident cloud migrations, how a top 5 bank ensured reliability with AWS and Gremlin. I'm joined today by Raj Jerrypachula, Senior Partner Solutions Architect at AWS, and Andre Newman, Senior Reliability Specialist for Gremlin. So Raj and Andre, I appreciate you both joining us today here at Tech Strong Learning. Andre, do you want to go ahead and get diving into your portion of our presentation today?
Yeah, definitely. Thanks, Cody, for that nice intro. Hey, everyone. Again, I'm Andre. Thanks so much for joining us all. I'm going to be walking you through a cloud migration that a top 5 bank did, showing you a bit about how they use Gremlin, how to use AWS, and the challenges they're trying to solve. So I'd like to kick this off with a question, as I do with a lot of webinars. What exactly does reliability look like at a top 5 bank? What are their goals for availability and uptime? What are they concerned about? And what risks to reliability do they face? And then second, you're going to look at their successes, right? When completing a cloud migration, this bank did a lot to both improve availability and reduce runtime costs, which is a hard thing to achieve for many organizations, no matter how large. So we want to look at how they manage this and how other companies like yours could follow their model without necessarily having to be at that same scale. So who are we exactly? Cody did a nice intro, but just to repeat, my name is Andre Newman. I'm a Senior Reliability Specialist at Gremlin, and I'm joined by Raj, who is a Senior Partner Solutions Architect at AWS. So first, let's start off with a bit of context about this customer and the initial challenge that they faced. So as we mentioned, they're a top 5 bank based out of the US. The services include things like corporate investing, wealth management, and of course, commercial and consumer banking. In total, they serve over 100 million customers. And they came to the table with a really clear objective, which was, how do we migrate our front-end IT services, including customer-facing websites and mobile apps, from this legacy on-prem data center that they were running to AWS? Or in other words, they needed to successfully migrate their front-end digital processes to AWS and also create an end-to-end solution for managing deployments to the AWS. Not only did they want to reduce the cost of actually running these services, but also maintain 99.99% or 4 nines of availability. And I'll dig into a bit more about what that means later in the next slide. So going a bit deeper into the goals, the bank split their goals into 2 categories, core or strategic and secondary. Core goals were to drive customer engagement and reduce churn. As it was explained by one of their site reliability engineers, whenever you have an outage or some sort of failure, you're reducing customer engagement and placing friction in front of them. This can, of course, lead to churn as customers get frustrated. So avoiding failures is key to keeping customers engaged. Next is, meeting strict regulation control and risk requirements. As you might imagine, banks, especially ones at the highest levels, have a lot of requirements for reliability and uptime. This makes moving to cloud platforms, especially public cloud platforms, a lot trickier since they have less direct control over their environments. They need to know that they can still meet their regulations and requirements, even if they don't maintain the infrastructure themselves. And the third core goal was to improve the employee experience for engineers. And firms like these hire a lot of engineers, and the key to an efficient engineering team is enabling each engineer to develop easier and faster. And more specifically, how do they give their engineers access to more modern cloud native development tools and platforms while also reducing the friction of running repeat manual tasks so that these engineers can work easier and faster? Now, outside of these core strategic objectives, the firm also had secondary objectives. First was delivering, or rather, improving and maximizing availability, or at least as close to maximum availability as possible, while providing the same or better performance. Next was reducing runtime costs by at least half. Cloud infrastructure can lead to cost savings compared to running your own data center. A lot of this comes from the increased developer efficiency and being able to scale more quickly. And of course, by not having to maintain and purchase all of your own on-site assets. The bank knew this and wanted to leverage it as much as possible to get the most benefit from AWS as possible. Still getting ahead of myself, sorry. They also wanted to automate an end-to-end reliability solution to handle things like self-healing and failure mitigation, to including things like testing, validating, and certifying new releases. The intent here is to build a pipeline and to keep the system up and running without requiring engineers to spend a lot of cycles doing manual reliability testing or manual reviews and things like that. And then lastly, probably the biggest secondary goal is completing the migration for all customers by the end of 2022. That's the date when everything needed to be fully transferred and pushed live. So kind of condensing all of these ideas into a single sentence, the bank needed to migrate its front-end digital workloads to AWS while reducing their runtime costs and maintaining at least 4 nines of availability. And for context, 4 nines only allows for about an hour of downtime per year or 10 minutes of downtime per week. So that's not a big buffer to work with. And that's when reliability becomes super important to make sure that you can meet that high demand for availability without pushing your customers or your costs to insane amounts. So why was moving to the cloud key to this process? Well, it's because cloud platforms are objectively more reliable than on-prem, right? Well, cloud platforms can offer better reliability compared to on-prem data centers, but you have to be able to configure them correctly. You have to know how to make use of all their options and all their available features and how they work within the context of your workloads. And the hard part is really knowing what correct looks like for your particular needs, your particular workloads, your particular deployments. And then, of course, having a team that can help you achieve that state. And so if we look at some of the risks and benefits inherent in cloud platforms, one of the main risks, of course, is that you don't really own the cloud, right? The big appeal of it is that you're able to hand off the infrastructure to another company for them to be able to maintain it themselves. And a big problem that a lot of teams run into is not properly configuring the environment for their use. So for example, auto-scaling is a key function of services like EKS and EC2, but you have to know to enable it and to configure it for your particular needs. The same goes for things like automatic failover, right? So let's say you have a surge in traffic. Not only will your application need to scale, but if that surge causes some of your applications or some of your workloads to fail or to shut down or to get overloaded, you have to know how to set up processes to be able to fail over to healthier systems. Of course, AWS has tools to help out with all of these, but it's really up to the customer to know where to find them and how to configure them properly for their workloads, or even how to ask for them. And next is sort of that lack of direct control that I mentioned earlier. A huge benefit of cloud computing is that you can leave the hardware and infrastructure to the cloud provider and then focus entirely on your applications. The downside to this is that you lose some of the control over your environment. The provider can manage the environment how they want. And while it's incredibly rare for providers' actions to cause outages, it is possible. So teams should be aware of techniques like cross-region redundancy to keep their systems running. And then last are dependency errors. These are errors within systems that you don't directly maintain or use, but that your application depends on. This is a risk no matter where you're deployed, whether it's on cloud or on-prem. The cloud architectures tend to be more distributed and make more use of dependencies, which means more dependencies. That being said, though, cloud platforms also offer benefits that you can't find on-prem. First is speed. You have a near instant access to all sorts of different types of deployment services, system architectures, and hardware types. All of these can be deployed in minutes, if not faster. Next, of course, is options. Cloud providers give you an enormous toolkit of services to choose from, as well as the frameworks to do things like massive scaling, isolated zones, and region redundancy. And last but not least is accountability. The cloud providers have a vested interest in keeping their systems and services available. Availability is directly tied for them to revenue and the trust of their customers. And even having a small outage can make a significant impact. So to support high availability, cloud providers have teams of engineers working specifically on managing reliability, which is a cost that most companies can't afford on their own. A top 5 bank like this could hire massive SRE teams, but that's really not their core competency. It's not what their business is focused on. Letting somebody else take on that responsibility means they can focus more on their business and their customers. So to bring all this back to the topic at hand, the bank wanted to leverage the benefits of the cloud, but they knew that there were risks associated with the move and things that they weren't aware of. Their goal was to minimize the number of risks and the scale of the risks that they expose themselves to, more specifically the reliability risks. And to do this, they needed a way to test their ability to withstand various reliability risks. And so they turned to AWS and to Gremlin to be able to help out with all of these requirements. And so now I'm going to hand it over to Raj, who will talk about the AWS side of this experience. So take it over, Raj.
Okay, set screen. Thank you very much, Andre. So I think Andre covered most of the stuff about cloud reliability, resiliency in the cloud. So I'll be talking more about specifically how we do things at AWS and what are the services available for you, how you can use the best practices that have been put in by AWS. So let's start on this one. My name is Shashiraj Jaripotula. I'm a Senior Partner Solutions Architect at AWS, and I work with ISVs, independent software vendors, and AWS partners, specializing in cloud ops and DevOps to develop joint solution and cloud adoption and help with the cloud adoption on AWS. So today we'll be talking about AWS well-architected framework, especially the reliability pillar, and how to build resiliency on AWS. So we will have some best practices. We'll talk about some of the technical services, the technical depth about some of the services. All those things we will cover in these slides that I have now. So let's start with the AWS well-architected framework. So well-architected framework helps you understand the pros and cons of decisions you make while building systems on AWS. The framework helps you learn architectural best practices for designing and operating secure, reliable, efficient, cost-effective, and sustainable workloads in the AWS cloud. It provides a way for you to consistently measure your architectures against best practices and identify areas for improvement. Here you can see 6 pillars of the well-architected framework, and in this session we will focus mainly on reliability. Let's talk about a shared responsibility model. Warner famously repeats, everything fails all the time. And this is true for any complex systems, whether in the cloud or on-premise. We do not need to accept failure in our systems. Instead, we build systems that will work despite those failures. So better build systems and think about all the scenarios that could fail the system, work on those fixes, and build that system in such a way that it doesn't fail. So that's what we are going to talk about in this webinar today. And Andre talked about some stuff, and I'll be talking about the remaining stuff. So in the AWS shared responsibility model, right, as far as AWS is concerned, AWS components abstract low-level failures like hard drives and power supplies. AWS services are built using best practices like redundancy. When it comes to customers, right, use tools AWS offers so the workloads follow best practices, and the chances of getting them in failure or in error mode are reduced. Let's deep dive on the AWS responsibility, that is resiliency of the cloud. AWS is responsible for resiliency of the infrastructure that runs all of the services offered in the AWS cloud. This infrastructure comprises of the hardware, software, networking, and facilities that run AWS cloud services. AWS uses commercially reasonable efforts to make these AWS cloud services available, ensuring service availability meets or exceeds AWS service level agreements. So when it comes to customer responsibility, right, it is resiliency in the cloud. So what it means is your responsibility will be determined by the AWS cloud services that you select. This determines the amount of configuration work you must perform as part of your resiliency responsibilities. For example, if you are using EC2, Amazon Elastic Cloud Compute, right? This requires the customers to perform all of the necessary resiliency configuration and management tasks. Customers that deploy Amazon EC2 instances are responsible for deploying EC2 instances across multiple locations, such as different availability zones. For example, there's an earthquake or there is a natural disaster, right? One of the availability zone can be going down or it's not reachable. Then if you put your applications on different availability zones, right, the chances of your website working uptime is more, and people who are using your websites, they are still on the website and they're not getting kicked out of the website. So implementing self-healing, right? Use services like AWS autoscaling, as well as using resilient workload architecture best practices for applications installed on the instances. You can also use managed services such as Amazon S3 and Amazon DynamoDB. AWS operates the infrastructure layer, the operating system, platforms, and customer access the endpoints to store and retrieve data. You are responsible to store, for managing resiliency of your data, including backup, versioning, and replication strategies. So this is the shared responsibility models where AWS does some of the stuff, and then it's the customer who does the remaining stuff to make sure we are compliant in the cloud. We need to build systems that embrace failure as a natural occurrence. So this is called reliability. Let's dive deeper into the reliability design principles. Let's think about how we might think about reliability in a traditional environment. We often test if things are working normally. We check if it meets expectations, but we rarely test what happens after things fail. So the first time we test our recovery process in the middle of a live reliability failure, it's not a good learning experience. This is why you used to see a lot of systematic failures. X failed and then Y failed. Y being the thing we never got tested because we didn't test X. So now X is working, but now you see that Y is not working. So these are some of the things that you should look into while testing your features before going into production. When a failure occurs, we manually fix it. If it happens a lot, we write down the procedures for fixing, maybe writing a manual process, doing it manually. So it takes time also. So that's, you're using time also. And we had to guess how much we need. So if we got that wrong, right, we had long provisioning times, which could lead to outages. And we made changes to our environment manually, which introduced this opportunity for human error. In the cloud, constraints have been removed that allows us to adopt these design principles to build and operate cloud native architectures, to test beyond destruction, to make sure recovery procedures are automatic and successful. We can have multiple resources answering requests, such that a failure in any single component always has siblings who can step in and absorb the load. So this is in regards to auto scaling. We can use the horizontal scaling to meet demand, and then we can make changes to our environment. We can do that through code and apply the same best practices we would apply to application code. Let's talk about automatically recovering from failure. So how do we do that in AWS? What is automated recovery? If you have to pay someone, wake them up in the middle of the night, get them to read what has happened, then get the run book and start executing, you lose valuable minutes. AWS are services that can help or provide recovery as part of the service. So if you look at RDS and Road 53, right, it helps you with automate recovery. If you are using auto scaling, it can help you with built-in recovery. And you can use services like S3, which is built to be highly resilient to failures. So why do we use automated recovery? If you have to page someone, I think we just covered this one. Let me go to the next slide. To recover from many failures, right? Killing and replacing the EC2 instance is often a good approach. You need to configure autoscaling to do this with the right health checks and design your applications to be stateless. For example, you can store your state information in something like Elastic Cache or DynamoDB. You should also note that autoscaling will drain requests before killing an instance. So as I mentioned, put up good health checks to make sure that your instances are behaving as within the thresholds. And if it goes beyond the thresholds, that's when autoscaling kicks in and it will create a new instance for you. So it's all automated for you. You don't need to worry about manually killing a EC2 and restarting an EC2. So make use of something called as autoscaling. Also, like AWS, right? So Route 53 health checks can monitor your workload endpoints and fail out a different region if a failure is detected. For example, as I mentioned in the availability zone, right? The same applies for the region also. If something goes bad in a particular region because of a natural disaster, Route 53 automatically has the health check, and then it sees that the region is not behaving properly. So it makes an immediate shift to the next available region where the applications are running so that your users are not impacted. Also make use of multi-availability zone RDS databases, which will automatically fail over to the secondary database if the primary were to fail. Let's talk about the test recovery procedures, right? So how do you test the recovery procedures now that you have your applications, they are running fine, you have used auto scaling, you have done horizontal scaling, and then you have put all the health checks, Route 53, all those things, right? But now you are assured that everything is going to work fine. But how do you test it before you are putting it into production? So let's talk about some of the options that you have here. Here you can use engineering tools with companies like Gremlin, Chaos Monkey, Pumbaa, etc. to resiliency. So today we are doing a webinar with Gremlin, right? So look into their offerings and see how you can do chaos testing in your applications and make them resilient. You can also build your own to stimulate failures. So we have AWS well-architected labs where there are some sub-modules like testing resiliency of EC2, RDS. How do you test EC2s? How do you test RDS? How do you use all these failures, learn from failures? So this is where chaos engineering works. So I'm going to share some good handout material after this call so that you can get some resources to go and look into. Then we'll also talk about how to access Gremlin, where to buy Gremlin in this webinar. So another thing is like stop guessing capacity, right? So this is where I would encourage you to go and provision, look at your metrics, right? Look at your KPIs, then I find out the demand for your applications. Use auto scaling as needed. Go and change the thresholds as needed. So you can use auto scaling in EC2s, container tasks, DynamoDB throughput, and other services, right? Just to make sure that when your application is being hit by a lot of new requests or a lot of more requests, right? Auto scaling triggers and it will spin up the additional instances for you. It will improve the throughput for you in DynamoDB. It will add more container tasks. So this is all available for you in AWS. So please make use of those features. Now let's talk about Gremlin, right? So what is Gremlin? So Gremlin provides an enterprise service to safely, securely, and simply run chaos engineering and chaos experiments that prevent outages and reduce downtime and is part of AWS partner network. So Gremlin is also an AWS advanced technology partner with DevOps ISV competency. So if you're not looked at AWS Marketplace, right? So this is a great opportunity for you to go and look for AWS Marketplace, search on Google or on AWS console and say, find me AWS Marketplace, right? So what AWS Marketplace is it's an online store that helps customers find, buy, and immediately start using the software and services that run on AWS. So Gremlin is available on AWS Marketplace. So once you go to AWS Marketplace, in the search bar, you search for Gremlin, you will get to this page. So this page has like a lot of various options on pricing. There could be a free tier, there could be a paid tier. So just go and look into this pricing and see what suits you, right? Maybe you want to try something as a trial. There could be trial available. So look into all those options, and then if you think that yes, this is the right solution for your company, then definitely go and provision Gremlin directly from AWS Marketplace, and it will tell you all the steps that are needed for you to install Gremlin, configure Gremlin with AWS, all those things. Finally, these are some of the resources that I would like you to go and look into. So these are some of the best practices. It talks about AWS well-architected framework. It talks about reliability pillar. In the reliability pillar, what you need to look for and what are the best practices. And when you create your applications, right, you need to ask some of the reliability questions, right? Like how is my solution reliability? If it is EC2, right, is it reliable? Then it will give you a set of questionnaires, right? Go and answer all those questions. And while going through the questionnaire, right, it will give you also confidence on how secured, how reliable your product is, right, when it is going into production. And there is also well-architected labs for reliability, as I talked about, EC2, RDS. So if you have something running on EC2, right, do these labs. These labs will tell you how to test for reliability for your EC2. It will teach you. So do those, and also for your RDS. And then Amazon Builders Library, right? These are vast resources of all the things that AWS has written, all the best practices, what it thinks is like good for customers to start reading on your own. Then it will also tell you where to reach out to if you have any questions, if you're trying to implement something. If you want to reach out to a partner like Gremlin, what are the contacts there, how to reach out to them. So all those things are available for you. And as part of the handout, these links will be in the handout section. So please make a note of them, copy them, and after this webinar, right, just go through and look into it. There is a lot of information for you to help with your journey, like the chaos experiments, chaos testing, and also like AWS, right? If you want to learn AWS, right, these resources will definitely help you. So with this, I will hand it over back to Andre to talk about more about the use cases that we ran for the bank. But Andre was talking, so we'll continue, and then we'll also have a demo. So Andre, handing it over back to you.
All right, awesome. Thanks, Raj. I could definitely say from personal experience, the well-architected framework helped me out when I was trying to figure out and get started with AWS, and when I started out at Gremlin. So definitely recommend, at the very least, checking that out and seeing what's in there, because it could probably help you too. So we've gone over the challenge that the bank faced. Raj showed us about AWS and how they were able to use it to meet some of their needs. So now let's talk a bit about where Gremlin and this idea of reliability testing fits in. So at its core, Gremlin is a reliability testing platform. Basically, we give you the tools to identify reliability risks before they have a chance to actually appear in production and impact your customers. And there's kind of a three-step approach to this. First, we try to help you find and prioritize your key risks, right? This answers the question of what are the parts of my system that could fail and how do they impact my overall reliability of my system? So to help with this, Gremlin gives you a suite of tests that you can run to test these different aspects. And also gives you the tools to watch your systems to see how they respond to those tests. Next, we measure the impact of those risks by assigning a score to each of your services. So let's say you have a critical service, like a service that handles authentication or user login or things like that. Gremlin can track that service's reliability by giving it a score out of 100. And this score will change over time, ideally improving as engineers implement fixes and repeat the test. So from there, engineers can automate Gremlin so that it becomes part of their day-to-day operations. This means scheduling regular reliability tests or running tests as part of their CI/CD pipeline or as their regular release cadence. This is important because, as we all probably know, software changes over time, so does the environment that it's running in. So repeat testing ensures that these changes don't introduce new risks or reintroduce old risks or regressions. And so in practice, here's how it looks. And I'll get into a demo later, but I kind of want to give you the overview of the flow beforehand. So teams that are starting out with Gremlin usually begin by recreating past incidents and outages that they've gone through themselves. Really, the only way to understand the resiliency of your systems is to test them, and we firmly believe in that, which is why Gremlin includes a suite of chaos engineering experiments that you can choose from and customize. We also want to offer pre-built reliability tests to give you a little bit more guidance and look for things like common issues and best practices. Once you've done that, you can use this data that you found and the results that you've seen to highlight your biggest reliability risks. So Gremlin creates those reliability scores for each of your services based on these tests. You can automate and repeat these tests to make sure that your reliability posture is up to date. And as you find risks in places where the test is going down, you're able to manage them like any other risk in your organization. It's really to give you that visibility so that you can drive action. Finally, as you run tests repeatedly and are able to fix specific risks, this builds confidence in your systems over time. Right? With things like reliability scores and dashboards, you're able to constantly and measurably improve your reliability at the infrastructure level, at the service level, and ultimately at your organization level. And of course, automation is key in this. You want to automate tests once they're passing, so you continue to have that coverage and don't have to think about it until your results begin to change. And you get that continuous visibility into your systems and your services and their individual reliability postures. And over time, as that builds up, that makes your organization as a whole more reliable. So start one bit at a time, and ultimately that brings everybody up. So now I'm actually going to quit out of my slides and show you a demo of Gremlin so you can see how this works in practice. So I'm actually going to start with my demo application. So for this demo, we're going to be testing the reliability of a fictional online banking service called the Bank of Anthos. This is actually an open source application running on Kubernetes. If you're interested in trying it out, you can pretty easily find it on GitHub and run it yourself. But for now, we kind of just use this as our demo environment to show you how Gremlin works. So with Gremlin, we're going to focus on three things. First, we're going to recreate an outage using a chaos engineering experiment. Next, we'll run one of those standardized reliability tests that come out of the box with Gremlin that I mentioned earlier. And finally, we'll see how those tests help us understand reliability risks, both for the individual services that we're looking at and for our overall organization. So kind of stepping through what the website looks like from our user's perspective, it's pretty simple. We log in, we have our account number, we have our current bank balance, we can deposit funds, we can send payments to other users, and we can also view a history of our transactions. So now each of these features is a separate standalone service. Think of them as their own separate container, or if you're familiar with Kubernetes, their own separate pod. And our website front end is actually another service that retrieves data from each of these services to display to the user. So as engineers, it's our responsibility to make sure that our bank is resilient, that all of these services are working, and that it's all coming together in a way that our customers would want to see. If not, our customers might not be able to access their accounts, which of course is a poor user experience and erodes trust in our bank. So we definitely want to avoid that. And the way we do that is by testing. So now I'm going to switch over to Gremlin. When you normally log into Gremlin, you'll see a getting started page, but I wanted to jump right in and show you what it's like to run an experiment. So I'm going to go over here to experiments. Now, I want to know what happens to my banking application when the service responsible for showing transactions, in other words, this service, is unavailable. And in short, an experiment is a way of injecting failure into a system. This allows us to see how our systems respond to that failure so that we can implement fixes. Experiments are meant to be open-ended by design. We can use them to recreate past incidents and outages, or try incidents or outages that we've heard of, like say in the news or for other organizations. We can make sure that our observability tools are instrumented correctly, and also just to get a sense of what the user experience is like under various failure modes. So to start out, I'm going to click New Experiment. Gremlin will ask us to select the systems that we want to run this experiment on. We can select from host, containers, or Kubernetes. Since this bank is running on Kubernetes, I'll select this. It'll select my cluster by default since it's the only one in this team, and I can choose a namespace if I want to, but just by default leave it at all. Again, the service that I want to test out is the transaction history service, so I can just type transaction, and it will come up in the search box. And when I select it, Gremlin will show a diagram of the selected the systems that I selected, just so I can verify what my experiment is going to affect. So I can just come here and confirm that it's only going to hit this one pod without impacting any other pods, at least not directly, right? This pod might cause, or rather, losing this pod might cause other pods issues, but for now, we just know that we're going to be impacting this one. So next, I'll scroll down and expand Choose a Gremlin. Here's where you can pick from all of our different experiment types, split up into 3 different categories. Now, I want to see what happens when the service appears offline. So I'm going to go to Network, and I'm going to select Black Hole. And what this experiment does is it blocks all outbound network traffic from this service. By default, it's for 60 seconds. I could specify specific IP addresses or host names or ports to target, but I just want to leave this blank, which will target all traffic. And then I'm going to click Run Experiment to get that started up. And in the meantime, we can watch as Gremlin spins up this experiment. The way it works is we have the Gremlin agent running on a Kubernetes cluster. The agent will check in, notice that it has an experiment to run. And so it'll actually orchestrate the experiment on that cluster. The agent only requires outbound access over port 443, so you don't need to set up like complex firewall rules or punch holes in your firewall. And Gremlin will also automatically determine which agents to run the experiment on, so you don't need to remember where you deployed certain agents or where your target is. And once our experiment enters a running state, we can come in, refresh the page, and try experiencing the way a user would, knowing that this service is unavailable. You might have noticed that it took a little while. It was spinning while trying to refresh the page. And when it did finally refresh, we get this error message of could not load transactions. The good news is that our website is still functional. But the bad news, of course, is that this isn't an ideal customer experience. Like, imagine if you're a customer logging in to make a deposit, like let's say it's payday and you want to deposit a check, or you want to see if a payment went through, and you log in to see this message. Like, you can just imagine the type of calls that customer support would get. Now, there are a few ways that we could fix this. One way, if you're familiar with Kubernetes, might be to scale up your deployment so that you have 2 instances running at any given time. So this way, if one fails, you can automatically fall back over to the other and it can pick up the remaining traffic. We could test this by, let's say, running our Kubernetes command to scale that up, and then going back to Gremlin and just clicking rerun to repeat this experiment and testing the site the same way as before. But since this experiment ended, I can come back here and refresh the page, and we should see that our transaction history is visible again and the website's returned to normal. Of course, in this case, it's not, which could indicate that the pod actually failed in the background. But either way, it revealed an issue that we're going to want to look at and fix up a bit more. So these are the type of insights that you can take away from tests like these. Sometimes you get results that you expected. Other times you get results that you didn't expect. But in any case, it's an opportunity to use those insights to implement fixes and grow. And actually, I'm going to check one more time. Okay, now we're back to normal. All right, so that was a single standalone experiment that helped us identify a single reliability risk. But we do know that risk can be anywhere. So let's say, what if we wanted to run multiple different types of tests on this service? Or if we wanted to see, we wanted to track a specific suite of tests. Or let's just say that we're brand new to reliability testing and we don't know about black hole experiments or anything like that. And we just want somebody to tell us, here are the tests that you should run. In that case, we can actually save this transaction history service in Gremlin, have Gremlin generate a suite of ready-to-run tests based on the most common reliability risks, and also track our ability to pass or fail those tests over time. And that's where services come into play. And so with services, it's pretty much what it sounds like on the tin. We're able to add each individual service that our team or our teammates manage. We're able to track it in Gremlin. We're able to get a list of tests that we can run on these services. We're also able to connect our monitors, our most important monitors and metrics to Gremlin using a feature that are called health checks. And these monitors are what tell Gremlin whether or not a test is successful or if it's failed. So for example, I can click into this front end service. I can see my reliability score and what it's made up of. I can see how the score might have changed over time. And I can also see individual tests that I can run. I can also see if they failed or if they passed, what the last run was. I can view the history of runs. and I can also run this directly too. And where the health checks fit in is that as I'm running these tests, let's say we click into this one, Gremlin will continuously monitor any health checks that I have attached to the service. So in this case, I have one that's just checking if the front end is available. It'll keep doing that throughout the test runtime. And if it comes back as a failed, then Gremlin knows that, okay, my service is unhealthy, so I should fail this test. Otherwise, if they report back as okay and the test completes on time, then they'll report back as successful, and Gremlin will know that the service passed this test. But for right now, I'm going to go back to my services, and I'm going to pull up my transaction history service, which I added just before this, just before the webinar started. And this is to give you an idea of what it looks like when you first add a service to Gremlin. Of course, since we haven't run any scores yet, or rather, run any tests yet, we don't have a reliability score, or the score is set to 0. We, of course, don't have a trend line because the service is brand new. And you might also notice that each of the reliability tests that we offer are split into different categories. So we have a scalability test, which tests your service's ability to increase or decrease capacity over time based off of demand. We have redundancy tests, which test if one component of your service goes down, like a host or a container or even a zone, are you able to automatically fall back over to a backup or a secondary component? And then we have dependencies. These are automatically detected by Gremlin for this specific service, and it's based off of network traffic. So in this case, we can see that this transaction history service talks to this dependency here, this ledger DB, as well as a Postgres database instance. And with those dependencies, we can run failure tests, which are essentially a black hole test. They test what happens if you completely lose connection to those dependencies. We can inject latency into that connection with your dependencies so you can see what it's like when they're slow. And we also can test what happens if those dependencies have expiring TLS certificates, or rather, we can check to see if their TLS certificates are expiring soon. And we can also add or remove dependencies that might be relevant or irrelevant to us. And Gremlin will even try to surface suggested dependencies if it notices other sources of network traffic, but isn't quite sure if they're dependencies or not. So, of course, before I can run tests on these, you'll notice that these are grayed out. It's because I haven't added a health check for this service, so I'm going to go do that right now. I'll go back up here, click Add Health Check. First, we need to tell Gremlin what observability tool we want to use. So I'm going to go to Create New Health Check, and then from this list, I'm going to select Datadog. You can see we also integrate with a bunch of other tools, including AWS. But in this case, I already have Datadog set up, so I'll click that. I can choose from the different Datadog zones or regions or domains or whatever terminology they use for it, but I'm going to stick with US1. And now what I can do is, there's a couple things that happen. First is Gremlin will automatically go out and try to find any monitors that I have that are named after this service. So you can see that it automatically pulled up this service transaction history has a high error rate monitor. That's actually the one I want. But if it wasn't, I can go to this search box, type in a different term, and then click search, and Gremlin will pull up the list again. Or if I know the URL directly, I can just go to provide Datadog monitor URL and copy and paste it there. But I have this selected. This is what I want. I'm going to click Test Health Check to confirm that it works, and it does. And then I'll just click Create Health Check. And now this will tie this health check to my transaction history service. So as I go down and as I run these reliability tests, let's say I want to run the CPU scalability test. I'll click Run and then confirm that I want to run it. Gremlin will go out and run this test on my service and monitor this health check to make sure that my service is still stable. I don't need to go in and select any specific resources or go through and choose which Kubernetes deployment I want to attack. It's just all built there into the interface. All you need to do is go in and click Run. And while the test is running, we can track its progress if you want to and view any other details like execution details or log data or see what stage of the test we're in. But for now, we're going to let this run and then go back to another service. And I honestly wish I had a service that was in better health so I could show you what good looks like. But in this case, I've actually been lacking with my own reliability tests. So right now you're kind of seeing the service is in an unhealthy state. But the score breakdown is pretty simple. Successful tests contribute 100% to the score. Failed tests contribute 50%. And if a test hasn't been run in at least a week, it contributes 75%. And the reason for this is that we want to give points for a failed test because even though it failed, it shows we've taken steps towards improving the service's reliability. And even though we passed the test and it expired, we don't want to lose all those points because it shows that we did pass it at least once, even if it was a while ago. So these points are then averaged across each of these categories and then added together to give us the final score. And then after, let's say we have other teammates who have joined Gremlin and they've added their services as well, we can get this dashboard of all of our services across our entire organization. And this gives us sort of that company-wide comprehensive 30,000 foot view of where your best reliability, where your most reliable services and your most unreliable services are. So here we can see that this auto scheduling test service is doing pretty good with a 89 reliability score that's actually improved over time. And if we reverse that, we see we have a lot of services that have 0 or very low reliability scores. And it could just be that we haven't run tests on these services yet, but still, it's a really strong indicator that we have a lot more work to do. We have a lot more to go back and start testing. And we want to make sure that we get these scores up as high as possible, just to make sure that our systems are as resilient as possible. All right, so just a few moments, I've kind of shown you how to recreate an outage with a custom cast engineering experiment. We saw how to create a standardized test and run that on a service. And we even looked a bit into how to use the results of those tests to better understand our reliability posture and where we need to make improvements. So now you've got a really good in-depth look at Gremlin. I'm going to head back over to my slides and we can start to wrap up. If I can actually get this viewed right. There we go. All right. So we covered a lot. What's the result, right? What did this bank actually get as an outcome of all this work that they went into? So I'm just going to go over like a sample of the test and results that the bank achieved. But I just really want to highlight the types of challenges they had and the types of challenges they would have had if they hadn't done this testing. So one of their tests was pretty straightforward. Does their EKS cluster's horizontal pod autoscaler work as expected? That's running that CPU test that we saw earlier. In this case, they found that it didn't, much to their surprise. So the action that they took from that was they need to go back over their rules for scaling and also be able to retest them. And that was how they were able to make sure that they were able to scale effectively. Another test was, can we automatically fail over to a second region? That's that zone redundancy test that I showed you in the product. What they found was, again, despite building scenarios that they thought met that criteria, they couldn't actually fail over the way they expected to. So similar to the first test, they adjusted their failover criteria, applied it, and reran that test to make sure that it worked. And the third test that they ran that they were surprised by the results was, if memory utilization is high, if we run that memory test on a service, can the service autoscale? And the answer was yes, but the memory utilization didn't scale back down. It stayed up at that high level that it was during the test. And while that might not have a significant impact on reliability, it did have a significant impact on cost. So by making sure that they were able to scale back down, they were able to save a lot on resource usage costs. And the way they fixed that was actually by removing memory from their scaling criteria and focusing slowly on CPU instead. So to summarize what their outcomes were, they moved to 100 million customer accounts ahead of schedule and below budget. Huge success there. They discovered more than 50 reliability risks that they were able to identify, fix, and validate before they ended up launching this new deployment to customers. They were able to show the output of these tests to the regulators to show that the systems met the resiliency requirements. And then they were able to ensure that they had their observability tools instrumented correctly, so they were picking up the right metrics, and they were able to get fast feedback on how the systems were performing. And then lastly, of course, They have their internal runbooks that were built for their on-prem data centers. They were able to validate that those runbooks worked for their new environment and to change them so that they were able to use them, or that they could use them in case an issue did happen in the future. And I also wanted to share some direct quotes from members of the site reliability team. First was to spend a lot of time thinking about scale and impacts, whereas operational excellence is making sure that we can be as prepared as we can be. The precision with which you can craft scenarios in Gremlin is very helpful, specifically for testing those unique conditions that might be unique to your specific services or your deployment. This is one that just makes me happy. Gremlin just makes life so much simpler. That's really what we're trying to accomplish here. We want to help make the lives of engineers and our customers a lot easier, and so that they can move faster and focus on what they really want to focus on. And then this is also one that I like. We know that if we don't do this better, that's a P1 or a priority 1 issue just waiting to happen. There were some very meaningful outcomes. The more we can do to prevent high severity, high visibility, on hands on deck kind of issues and outages, the better off everybody's going to be. So we want to make sure that what we offer helps avoid these as much as possible. All right, and that's all I had for slides. So thank you all for joining us. I'll turn it back over to Cody.
Awesome, Andre and Raj. That was great. It looks like we have received just a couple of questions, so I wanted to go ahead and start tackling those. So our first question says, does this Gremlin demo part, can it be set up on how many clusters? And sorry, I'll go ahead and just maximize this so everyone can read it. But can it be set up on how many clusters, and what is the actual outcome?
Yeah, so I believe for our trial, you're able to set it up on as many clusters as you'd like. It's a 30-day all-access trial. So in this case, I only had it running on one cluster. Honestly, I recommend starting small with just one cluster, just so you can get a better sense of how it actually works and how your services respond. But regardless of where you set it up, there is always a potential for good outcomes to come out of it. It just depends on what your setup is and what applications you're going to be testing. So
all right, and Andre, oh, yes, hopefully. If that did not answer your question, participant 130, go ahead and send in another question and we'll try to answer it again. So Andre, I believe we have 2 more questions, but they're in reference to slide 9 in your presentation, if you wouldn't mind jumping back to that. And we received these questions pretty early on. But yes, it was this slide right here. And it says, for the first bullet, can Kubernetes take care of that cloud-related risk?
Oh, okay. To a degree. I mean, you still have to be aware that even in Kubernetes, you still have to tell it how you want it to respond to things like autoscaling. So you still have to set up that horizontal pod autoscaler. And even for vertical autoscaling, a lot of that is built into your cloud platforms like AWS. You still have to tell it the maximum number of nodes you want it to create or what type of node you want it to create. So while technically, yes, it does still require you to set it up first.
Okay. And that same participant asked in regard to that second bullet of no direct control over hardware. They said, isn't that a feature?
Yes, it's actually both a feature and also a, well, depending on your needs, it could also be a curse. It's a benefit because, kind of like I mentioned, the provider is the one who handles that. It's their expertise that's managing that system. The downside of that is that you don't really have direct control over that hardware. You can't really dig into it as well as you could for, let's say, like a server that you're running on-prem. So you have a bit less visibility and a bit less control over it, but you can also rely on the experts to take care of it for you. So it's a bit of both.
I think there was one question which I already answered, but if there's a follow-up question on auto scaling, then I can talk more about it.
All right, it looks like we've received, looks like a bit of a specific question, but we'll go ahead and put it up on the screen and read through it. So AWS Graviton 2 instances map to a CPU core. x86 is SMT and the behavior on container are very different. Do you have a Graviton 2 specific Gremlin test load tools?
Ooh, that's a tough one. I don't actually have an answer for that.
Yeah, I think we have to see if Graviton is supported on Gremlin, because we have some partners where they have successfully run all their tests on Graviton. But Gremlin, I'm not sure if a specific test was done on Graviton to see if it is supported or not. But it's a good question for follow-up, as Andrew said.
Yeah, it's definitely a good follow-up question.
Perfect. And we'll make sure that these list of questions do make their way back to you guys so that you can follow up. And we can hopefully respond to those questions that way as well. So we do just have a couple more minutes and no more questions on the docket. So I did want to give each of you an opportunity to leave our audience with any golden nuggets you feel you need to leave for them, or something that they need to absolutely solidify in their minds before we close things out.
Yeah, so a couple of things, right? Like there was so much information fed in this webinar. We talked about reliability, we talked about resiliency, then we talked about some of the tools that AWS provides to help you with your cloud journey, and then how Gremlin helps you with your chaos testing, all those things, right? There's so much covered in this 1 hour, and there were some resources in the handouts. So I would encourage you to go through all those things. And there are some forums where we actively talk and discuss about all these things. So please join those Slack channels. Like there's a developer Slack channel, AWS developer Slack channel. If you're a developer or you're like a tester, please put those questions there. Myself or somebody else from AWS will definitely try to answer if you have more follow-up questions on this one.
Ooh. And I would just add, just in general, when approaching reliability, you don't have to be a top 5 bank to do it. We recommend that everybody does it and tries to get into it. And you also don't have to go in all in at once, right? You can start slow, just running a few tests at a time, and gradually build up as you get more familiar with it. But definitely take advantage of all the resources that AWS has. Gremlin also has a bunch of resources on our website that you can access for free. So don't hesitate to reach out, to look into those, and to ask if you want additional info.
Awesome. And in regards to those AWS resources, they are available in the handouts panel right now. So feel free to grab those while we are closing things out. So Andre and Raj, thank you both so much for joining us on Tech Strong Learning. It was a joy to have you both back on here with us.
Thanks
for having us.
Thank you, everyone.
So I would like to remind our audience that our session was recorded. Should you want to rewatch or maybe share this program with a friend, you will be receiving an email with a link to access the recording on demand. You can also find it living on the DevOps website at devops.com/webinars, and be sure to look in the on-demand section. It should be there soon. The 4 winners of our $25 Amazon gift card drawing, they are Sherry H, Taj A, Gidrius V, and San M. So to our 4 winners, congratulations. Keep an eye on your inbox to claim your gift card. It should make its way to you in about the next 48 hours. But if you don't happen to see that email, check your spam folder just in case it happens to get filtered out. I'd like to thank AWS and Gremlin for sponsoring this program today. And to everyone who has been with us for the past hour, thank you so much for being here. We really appreciate your time, and we also appreciate your feedback. As soon as we close out, there will be a survey that pops up. Just let us know what you thought about this program, or if you have recommendations, suggestions, ideas for future topics, of course, let us know that as well. Either way, we do hope to see everyone at a future Tech Strong Learning experience. Have a great rest of your day, and Raj, Andre, thank you both once again.
Thank you very much.